All right, if you're deep into your GCSE computer science revision, you know that just writing code that works isn't enough. Writing good code, well, that's where the top marks are. And today, we're going to dive into one of the most powerful tools you have for that, subprograms. Let's look at how they help you build programs that are clean, super efficient, and way more powerful. We've all been there, right? You start a new project and things are going great, but then you add a new feature, and another one, and soon your code is just this massive, long scroll. You're copying and pasting the same chunks of code over and over, and before you know it, it's a complete tangled mess that you can barely even follow yourself. You know, there's actually a name for this in the programming world, spaghetti code. And it's the perfect name, isn't it? Just imagine a plate of spaghetti. You can't see where any single noodle begins or ends. It's all just a jumbled mess. And that kind of code, it's confusing, and it is an absolute nightmare to fix when something goes wrong. But here's the good news. You don't have to live with that spaghetti. There's a much more elegant way to structure your code that's going to make your life, and especially your GCSE projects, so much easier. This is the journey we want to take. We're moving from the problem on the left, that repetitive, hard-to-read spaghetti code, over to the solution on the right. Look at those words. Reusable, easy to test, clean and organized. This is the goal, and the tool that's going to get us there is the subprogram. So what exactly is a subprogram? Well, the official definition, the one you'd want for an exam, is right there, a sequence of program instructions that performs a specific task, packaged as a self-contained unit. But think of it this way. It's like writing a chunk of code, giving it a name, and then you can just call that name whenever you need that job done. It's a reusable little help. Now, subprograms come in two main flavors, and it's really important you get the difference. Over on the left, we have a procedure. A procedure just does something. See the example? The greeting procedure just takes a name and prints a message. It does its job, and that's it. But on the right, you've got a function. A function is different because it always returns a value. The triple function here takes a number, does a calculation, and then sends that new number back to your main program. I love this quote from the OCR guide because it just sums it up perfectly. A function is like a mini program within your program. It's such a great way to think about it, right? A little self-contained piece of logic that you can just call on whenever you need it. So let's see how this looks in the real world. On the left, you've got the pseudocode for that triple function, and on the right, that's a real Python function. The key things to spot here are the def keyword, which means we're defining a function, and the return keyword, which is what sends the value back. And yeah, the example's called spam. That's a classic little nod to Monty Python for you. So, using a function is really just a simple three-step dance. Step 1, you define it. You create that block of code with def. Step 2, you call it. You just use its name to make it run. And step 3, you use the result it gives you back, usually by storing it in a variable. So define, call, use. It's really that simple. Okay, theory is great, but let's see how this all works together in a more practical example, one pulled straight from the guide. We're going to look at a little text-based adventure game. This is perfect for showing you how a few different subprograms can team up to make your code super clean and easy to read. So our first building block is a really simple procedure called intro. Look at the code. Its only job is to print the starting message for the game. That's it. It's small, it's focused, it does one thing, and it does it well. This is a perfect example of a procedure. It just performs a task. Okay, the second piece is a function called choice. Now, this one's a little smarter. It asks the player to pick a door, and it's got a while loop to make sure they actually type 1 or 2. But the most important part, the thing that makes this a function, is that last line. It returns the valid choice. It sends that value back to whoever called it. And the third piece is check door. This is where it all starts to connect. See how this procedure takes an argument called chosen door? Well, that's where the value we just got from our choice function is going to go. The main program will take the result from choice and pass it into this procedure to figure out what happens next. So after we've defined all our little helper subprograms, what does the main part of our code look like? Look at that. It's just 3 lines. First, we call intro to set the scene. Then, door number equals choice runs our choice function and saves the result. Finally, we pass that result into check door. It reads just like a story. It's clean, it's logical, and there's no spaghetti. And this is the whole point, really. Instead of one giant tangled program, we now have these neat, reusable building blocks. Each subprogram has a very specific job, and because of that, we could use that choice function in a totally different part of our game later on, and we wouldn't have to change a single thing about it. So, what's the big takeaway here? Learning to use subprograms properly is like unlocking a programming superpower. It lets you break huge, scary problems down into small, manageable pieces. It makes your code so much easier to test and fix, you stop repeating yourself. Programmers call this being DRY, don't repeat yourself. And honestly, this is exactly the kind of smart, structured code that examiners want to see in your GCSE project. So I'll leave you with a challenge. Think about a program you're working on right now for school. Is there a chunk of code you've copied and pasted more than once? A specific task that keeps coming up? What piece of that code could you untangle and turn into its own clean, reusable subprogram today?